Hi, everybody. Thanks very much for joining us for this afternoon's webinar. This is the second of 3 parts of greenhouse automation today. We have some guests. We have Matt and Peter, one from AdeptAg and the other from Ritter. And then, of course, we've got Dave, who is our general manager at the Prospient in Canada office. For those who've never watched one of our webinars before, if you have any questions, please use the chat. And I will ask them at the time if they are relevant. I'll ask them of the team. And if they're not relevant, then I'll just wait until the end, and then we can answer those questions as well. But feel free to use the chat however you need to. If you have any questions that come up, please do. At the very end, we'll give you email addresses in case you have follow-up questions. So with that, I'm going to hand it over to Dave, who is going to do some introductions, and then we'll get into it. There's a lot of content, so let's go.
All right. Well, thank you everyone for joining us today. We really appreciate you taking the time away from your day to come and see what we have to talk about here when it comes to our part 2 of our series. Today we're going to be talking about just the journey to start automation, really what things make sense up front. So for those of you who don't know me, my name is Dave Taylor. I've been in the industry now for going on 20 years, mainly in controls and automation, electrical. So that's the background that I keep working now for Prospient. I get the opportunity to work with structure, greenhouses, and it's really been a learning experience for me. So today, I've asked 2 friends here to join us today, Matt Van Gies from AdeptAg and Peter Yanow. If you guys want to go ahead and introduce yourselves.
Yeah, for sure. My name's Matt. Thanks for having me today. I've been in greenhouses for over 10 years. Got my first job in the greenhouse at age 15 and slowly moved through working with plants, greenhouse maintenance, and eventually to my sales role at Swart. Here to represent Swart Systems today, who I've been with for 4 years and in sales for 2 of them. It's kind of my brief background. Peter?
Yeah, thanks. My name's Peter Yanow. I've been with Ritter since 2013. I started with the motors division of Ritter, and then since moved into a sales role to represent every facet that Ritter that Ritter offers. Just on the personal side, I'm a father of 3 young children. So as much as I would like to put that my pastimes are golf, watching football, it's more spent doing laundry, dishes, and cutting the grass. So super exciting stuff.
Much better off anyway, Peter. Much better off.
Thanks. Yeah. The Lord's work.
Well, so like I mentioned, we're going to be talking about, we're calling it semi-automation, but really it's the path to getting to automating a greenhouse, right? So what things really make sense for you, how we look at these things. So the 2 items that we're going to discuss today are going to be irrigation. Matt's going to lead us in that, give some tips and tricks for things that he's done over the years and things that make sense when you're irrigating or automating irrigation. And then Peter's going to talk about controls, motorization, mechanization of the greenhouse to be able to, further the goals of what you're trying to do for the build. So yeah, we'll start off, I guess, by defining semi-automation. And really, I'm putting this is more of a roundtable discussion. So I'm putting this out to Peter and to Matt. So when you guys look at this with customers, really, what do you think about? What does semi-automation or the start to automation look like for you guys?
Start to automation, we're looking at basic Lego blocks, basic principles, getting automatic irrigation valves out in the greenhouse, hip valves, solenoid valves, starting to automate the flow of water, where it goes, how it gets there, the systems we use to do it, and then combining those fundamental building blocks with small scale controllers, individual misting controllers, rainbird clocks, things of that nature. That's the start for irrigation automation. That's where I would start, at least.
Yeah, absolutely. Would mimic exactly what he says. It's going from having manual operations, from hand cranking vents and hand watering plants to having that controlled very simply with a thermostat and like Matt was saying, just a simple solenoid to irrigate.
Great. And when does this make most sense for people? Like, I mean, is this something that you jump into out of the gate? Is this something that you get under your belt within a few years? What are your thoughts on that? I guess Peter, we'll start with you this time.
I've seen the full gamut. I've recently been dealing with a greenhouse that's been operating for years as a nursery, and they find themselves more and more away from the greenhouse, and especially in the wintertime when it's dead, but he wants to maintain a minimum temperature, but doesn't want to have to drive into his small operation. He wants to, view on his phone whether something's wrong or that he wants to be assured that his temperature is maintained. Just like I can ensure I'm here at work that my house temperature is maintained at a steady 72 right from my phone. So it's making it probably sound more complicated than it is, but it's simple, just keeping the temperature going right there. So.
Great. And Matt?
I mean, on a similar thread, there's not a lot of things in the greenhouse that you can say at a certain square footage you do this, and at X square footage more you do that. But at some point, it becomes impractical to continue to do all of these operations by hand, watering especially. As soon as you get into more than, running one full bay of a monocrop, regardless of what size that bay is really, and doing that on a scale of an acre or more. If you're not using automation, you're not automating those irrigation cycles. Like, we're not talking about payback in years, we're talking about payback in months, maybe even weeks.
Yeah.
These systems, especially just to get started, aren't crazy expensive.
Yeah. I might add, also if you're going from a hoop house with open sides, and you want to extend your season longer and close the sides to that's also a good start on automating.
All right, great insights. Thanks, guys. So Matt, I guess if you want to take us through your the irrigation, what you would recommend then for people that are just starting off and some places to start for them.
Yeah, for sure. Starting at the basics, like I was saying, hip valves. Some people might be surprised to hear there are many growers out there who still actuate all their irrigation cycles with a guy and a series of hand valves. Not only is this inefficient, but it can lead to errors and waste, as a grower may accidentally send the wrong feed to a particular crop, or allow the system to run for too long just because they left the site for a moment to help somebody else out. Solenoid valves take those touch points, put them into software where we no longer have to worry about them. Irrigation cycles can now be programmed to use specific supply lines and last for an exact duration thanks to solenoid valves. I know it seems simple, but valves like these, or ones like them, are the backbone of all the systems that I'm about to describe. So they're definitely worth mentioning. With that out of the way, got a few systems. I'm going to kind of do a little bit of the systems roundup. Sub-irrigation systems. Let's start on the floor with drip irrigation. Drip systems in various forms have been used for hundreds of years, with early examples of buried, unglazed clay pots being used to slowly release water to plants in China in the 1st century. It isn't particularly relevant to us, but I did think it was a cool piece of trivia. In the late 1960s, water experts developed the first systems that used friction to slow water release rather than small orifices. From that innovation, Netafim was born. Today, pressure compensating drip systems are cost-effective and widely used by growers to dose precise amounts of water to plants in hanging baskets, greenhouse floors, and field production. Years of R&D later, we have more advanced and technologically involved ways to deliver sub-irrigation to plants that don't like to have wet leaves. Trough benches deliver water to plants in a thin film running down a bench trough. They reached peak popularity in the 90s and 2000s and remain a flexible and cost-effective way to deliver sub-irrigation, especially for growers who'd like to recirculate water, as these systems are easily recirculated without requiring what some would deem as excessive water storage. Flood benches and flood tables use the same structure as trough benches, but use polystyrene liners to create a basin that can be filled and drained, allowing for more flexibility with plant spacing and allowing growers to achieve a greater depth of water, which is an asset for plants in larger containers. Flood tables like these take the same liners and concepts, but put them on a table in a movable rail system, making it easy to bring large quantities of plants in and out of the greenhouse for planting, treating, trimming, and shipping. This type of system is ideal for weekly growers who ship relatively consistently throughout the year. Flood floors offer the most versatility. They give a grower the ability to flood an entire greenhouse floor. This allows them to use almost any container, at any spacing, anywhere in the greenhouse. Zwart Systems concrete flood floors also allow you to roll carts anywhere on the floor, making for extremely fast harvesting. They also enable you to drive heavy equipment on the floors, offering the most versatility for automation and hard goods storage. Having looked at the floor, let's take to the skies. Sprinkler systems. Provided your plants can tolerate wet leaves, sprinkler systems are the most cost-effective way to water a greenhouse. Back in the 80s, 90s, and 2000s, we had to use multiple rows of pin or bow nozzles to water a single greenhouse. They were inefficient, clogged somewhat easily, and didn't yield the uniformity growers wanted. Nowadays, we can water a greenhouse up to 24 feet wide with a single row of sprinklers at a proven uniformity of over 90%. These systems are efficient with their water use, effective in their coverage and uniformity, and predictable in their operation. We now have tools that allow us to model the performance of a sprinkler in any application, with factors being sprinkler type, bay width, operating pressure, and height above the crop. We can predict what the coverage uniformity, distribution uniformity, and scheduling coefficient are, so that growers can know exactly what they're going to get before they have it. As you may have guessed, the benefits of these systems go beyond labor savings. No matter what system you choose, you yield the following benefits. Increased crop uniformity. No human can dose water to each plant more precisely than any of these automated systems. Better irrigation uniformity leads to more repeatable outcomes, leading to less time spent by growers tweaking and making adjustments. Irrigation uniformity also correlates directly with better crop uniformity, leading to more satisfied customers with less picking through the crop when it comes time to ship. Increased flexibility. Freeing a grower from running a hose or manually actuating irrigation cycles allows them to spend time on higher value tasks, like tweaking fertilizer recipe and environmental conditions. Additionally, automated irrigation allows you to start earlier in the morning and go later into the evenings without staffing or payroll consideration. This may even allow you to add on production without having to make investments in the irrigation room to water faster. But I can't talk about technology and overhead irrigation without bringing up booms. Booms are the most technologically advanced method of overhead irrigation that we have, and I think they should be a consideration in some form for almost every grower. Booms come in a few forms: dual rail, movable, and gantry. Dual rail booms are the most common. These booms have a spray carriage that runs on two rails up near the trusses of the greenhouse. This carriage carries a spray bar up and down a single greenhouse bay to irrigate the plants below. Zwart's Perfect Rain irrigation booms are offered with two spray bars, typically one used for irrigation and one used for misting. The spray bar can be divided into up to 8 rows along the width of the greenhouse, with each row able to be divided down the length of the greenhouse. Movable booms are typically a single boom that, unlike our dual rail, which we would install in each bay, are able to be moved anywhere in the greenhouse. Zwart's builds booms like this called Thunderstorm. They allow the user to move a boom by hand on a cart anywhere it's needed. It uses an integrated hydraulic piston to lift the boom to the rails on which it rides. Other versions, like those available from Robur, one of the companies for whom we distribute, mounts their boom on a rail system in the center of the walkway. This allows it to be driven by motors to any greenhouse bay and to be used also anywhere in the greenhouse. Gantry booms are a bit newer. They take the same spray bar, but instead of mounting it to a small central carriage, it fastens it to a full platform, the width of the greenhouse. It rides on rails along the post row. This gives you all the functionality of a boom and a monorail in one, able to be used to hang in harvest baskets as well as to monitor the crop. Some growers with gantry booms will even eliminate the center walkway they leave down the middle of the greenhouse, since they can now observe their plants from overhead. This allows them to get a little more out of the square footage they already have. Some of the key features of boom irrigation are uniformity. Sprinklers are good, up to 90% or better, as I mentioned earlier. However, by virtue of hanging in the middle of the greenhouse, they will always irrigate more densely down the center than they will at the edges. Booms provide perfectly uniform irrigation across the entire bay. Flexibility. While in theory you could divide a greenhouse into a few sections with sprinklers, it isn't common or efficient, and there's always overspray to consider. Booms allow you to divide a greenhouse into 8 crop rows with 99 plus zones down the length of the greenhouse. This means that for irrigation, and more notably crop applications, the user can choose to irrigate just a small portion of the crop in a greenhouse, saving water and chemicals. Additionally, booms have 2 spray bars and can also be run at many different speeds, enabling them to simulate everything from a very light mist to a heavy rainfall, as opposed to sprinklers, which are stuck at 1 flow rate and droplet size. If you're considering booms, there are some structure implications that are worth noting. Firstly, although this does fluctuate with greenhouse width, a dual rail boom weighs between 400 and 500 pounds typically, and a gantry around 2,000. Most new modern structures handle this load with ease, but it's a good thing to get out of the way when you're talking with a structure vendor about a new build. These booms also need rails to run on. Oftentimes, when we add booms to existing structures, we need to add rail pipe for these booms, adding to their cost and weight. However, they can also be run on heating line, which is often installed with that new build, provided those lines are sufficiently strong and located in the right place. I'd recommend 30-inch centers because that's the width we build our booms to, but consult with your structure vendor and whoever you're considering buying from. The gantry, on the other hand, is made to your specific rail spacing.
Can I ask a question on that slide?
Sure.
Which ones were the photos? Which booms were
Top photo there is the dual rail, which we would typically install in each bay of the greenhouse. However, that movable boom looks very similar. There's just a cart that you wouldn't be able to see that is associated with that. And the bottom is gantry.
Okay.
I chose the photo with our 2 guys riding on it because it gives you the idea.
Yeah, we've done a few of those gantries as well before too, and typically we will install the rails along the sides as part of the greenhouse structure as well too, as long as we know that the grower wants a gantry system in there.
Yeah, I mean, in summary, you can see that collaboration between vendors is the key to the success of these projects. As we've been designing, installing, and servicing these systems for decades, and we understand that each one is different. We work with growers to find the right combination of technology for their specific needs. Structure and irrigation are only part of the system, and in order to make use of their potential, you need a computer to control it all. A system that ties irrigation and structure together for perfect environmental management. Point at which it feels right to hand the discussion over to Peter.
Thanks, Matt. So a little background on Ritter and what we do. We started back in 1953 in the Netherlands when growers came to the owner of Ritter and asked him to create something to make it easier to open and close vents. Back surprising that even back that far in the mid to late 50s that they were adding motors to vents. As such, over time, we've expanded to a lot more areas. As you can see here on the left of drive systems, you'll see process automation. We don't call it a climate computer. It does more than just create the optimal climate. It actually it manages almost every process in a greenhouse, more than just climate as well. On the right-hand side of drive systems, we create the climate screens that help control things like the light and the temperature. And keep the energy inside of a greenhouse, and it complements the drive systems very well. And then moving down to the bottom row, row, water treatment. So just like Matt and his great company, Zwart, irrigate, if you're living in an area that restricts the dumping of water to the ground, it's equally important as irrigation to manage what you're going to do with the water afterwards. So are you going to collect it, sterilize it, and reuse it, which would save money when you fertigate again, or are you going to dispose of it in another way? And the next two areas are more common as you grow. So it's maybe the next step in a web series here, and that is greenhouse labor costs. So we also track the performance of labor, because that tends to be the largest operational costs of a greenhouse. And then lastly, robotics. Robotics are on the horizon. They're not fully mainstream yet. They're coming. We have one, and we say it's about 80% of the way there, but the last 20% is probably the hardest 20 to get through. So as I mentioned earlier, my where I cut my teeth at Ritter was in the drive systems, and everything we do for drive systems is specific to the horticulture industry. You won't find our motors in a car factory or any other industry other than the ag industry. So we typically handle three main types of operations with drive systems. So venting, opening and closing the top vents or the side vents. Screening, again, top screening, horizontal screening, and sidewall screening. And greenhouse strawberries, I mean, it's not, I'm sure it's not strictly specific to greenhouse strawberries, but in many strawberry applications, we're raising and lowering the gutters to make it easier to get in there and do the crop work for the employee, whether that's raising and lowering or swinging side to side. Now, all of our motors, they consist of two parts. There's the electric motor, where you connect your main voltage to, and we offer a wide variety. So that typically starts at 115 volts and goes up to 600 volts. So when you're considering starting to move into an operation where you're doing this, you really want to consider and together with your builder, what the supply voltage is from your utilities company. And then there's the gearbox that the electric motor's connected to. And on top of the gearbox, there's your limit switches. And that works in conjunction with a 24-volt signal, as opposed to the main voltage of the limit switch. So you can see in the top left corner, there's a rather large motors that we reserve for screening systems. And on the right-hand side are examples of our venting systems. They can also be used for screening, whether it's sidewall screening or top screening. And then the bottom left-hand corner is an example of a motor that we would use in a winching system. So different add-on features on the sprocket. If you're considering building a glass greenhouse, one type of glass greenhouse is a Venlo system, where the venting is done using rack and pinions. So basically, motor pushing and pulling racks through the pinion system and opening the individual vents. So just at a large 36-acre facility this morning, where all 36 acres was handled by a total of 8 motors. One motor controls the one side of the peak, while another motor handles the other side of the peak. Additionally, in glass greenhouses is the screening. What we have here on the right-hand side is a series of 3 screen motors, and pretty simple system for wire screening. It's just a motor consisting of a drive shaft and some pulleys to open and close the shades. So to do something of this size manually is just not feasible. But
what are we looking at on the left?
It's just showing the size of a greenhouse and this, the how big we could get with the screening systems, and kind of showing it's pretty impossible to do that manually.
Yeah.
Another type of greenhouse structure is venting. So in a poly, I picked 2 examples of venting. The first example being direct venting. So if we take the middle image as a complete greenhouse, we see 4 bays with double venting. So in a direct venting system, you'd have 2 motors per bay, or 8 motors total for this example, with each motor lifting each side of the vent. Conversely, there's an indirect venting system where 1 motor drives a series of gearboxes. And so a system like this, 1 motor could handle all 4 bays on one side. So you reduce the 8 motor system going direct venting down to 2 motors with the indirect venting. And then just like the glass greenhouse, poly greenhouses, it's also a good idea to think about screening in there. So it's also common to do wire screen systems in poly greenhouse. I also wanted to show a push-pull system where where a system consists of a motor with racks and pinions connected to the profile, where the motor turns one way, it'll either open or close the greenhouse. So this is also known as a set it and forget it type system. It's a little bit more costly, upfront costs because of the infrastructure of the added racks and pinions and push-pull tubes. But the maintenance on this is fairly low. Whereas in a wire screen system, you also want to consider reinforcing the gable ends because of the forces of the wires pulling. And then when it comes time to change screens, it's also a good idea to change your pulling cables and nylon wires. So I typically say our motors are like the guy that spends a lot of time working out in a gym. They're really strong, but they're really dumb. So they actually need something to tell. All they do is lift things up and put them down. So so they actually need a controlled mechanism to send them in one direction and the other. So this control box would be in between the electric motor and the climate computer. So what happens is the climate computer would send a signal to the control box to say, okay, it's time to open or close the vent or screen or what have you. And then once it reaches a desired position, it sends feedback to say, okay, I'm at this position and it's time to stop. So in the first example on the left, so these are just different types here. Our motors should preface this. Our motors do not care what control box you use. It just my resources happen to have the Ritter control pictures, so I'm stuck to showing these examples, but they all typically work the same. So on the left is the Ritter Logic Link. This is a control box that's mounted on the electric motor right from the factory. So as I mentioned earlier, our electric motors take high voltage and low voltage to the limit switches. The benefit of a control box such as this is the electric motor and the limit switches are wired directly from factory. The electrician on site is tasked with sending the main voltage to the control box and setting the limits, and then as well as the control wires from the climate computer. What we see in the middle is a similar type of control box in the way that it functions, but it's mounted in a box to be placed anywhere you want, and it comes with a hand control. In this instance, the installer did not want anybody coming by and manually controlling it, so he set it up high near the motor. The difference with this setup here is an electrician would then have to wire the main voltage, as we see in the first picture, but also the low voltage, the 24 volts for the limit switches, and the control signal wire from the computer. We see a similar setup in the last picture, and this is an example of what I would advise not to do. Here we're looking at this setup, I believe was 14 motors in total. It was extremely labor intensive, takes up a ton of wall space, and can be a nightmare to manage if not labeled properly. So this last picture kind of sets me up for this next photo, and on the left-hand side, it's basically two of the same photo. Is what we call a combination panel. So a combination panel handles more than just controls for the electric, for the vent motors. There's other processes that you may have in a greenhouse, such as fans and whatnot. So this is an engineered system that can be placed and easily manageable once on site and initially wired up by an electrician, but also one clean, centralized location for your power distribution and controls. And might I say also lockable. I'm a fan of control boxes being lockable and not accessed by anyone who might look at the vents or the screens and say, hey, I want this open. I'm going to override and do this manually. Slightly more advanced option for the motors, but also a safer option is digital limit switches. A new product we released this year called the Smart Drive. It's a digital limit switch mounted right on the motor. Setting up limit switches in our conventional motors that I showed previously is done with the use of an Allen wrench and some knowledge on how to set limit switches. With what I like to do when I demo this Smart Drive is I like to say nothing and let the people who come to visit me set up the limit switches on their own. It's simple, push button, easy to read functionality that in just a few minutes you can set the limit switches with no previous knowledge or guidance whatsoever. Now, this is a system because when we combine it with the picture on the right-hand side called the Smart Drive panel unit, it provides Bluetooth functionality to that electronic limit switch. And it also provides steerability while you're up at the motor. You can actually use the the buttons on the screen to drive the motor open and close. Now, this is mostly beneficial during the installation phase, or the installation phase of a new greenhouse, because it dramatically reduces the time it takes to set up the limit switches in a greenhouse by up to 75%. If you do have the panel module, which is an optional module, and you have your first limit switch set, you can then copy the limits to your phone via Bluetooth and subsequently go to each motor after that and upload the limits. So this saves a lot of time, because in a conventional setup, you have to send your vents all the way open, set the limits, and send them all the way closed and set the limits. So with the Smart Drive, after your first setup, all that time is saved after each motor. And there's added safety and diagnostics available from the phone. So those are some ideas of what to think about with the type of greenhouse you want to start automating. But what about the climate computer? It's really the heart of the greenhouse. It's a system that automatically controls all the processes inside. So when we talk about a climate computer, like I mentioned earlier, it's really a full process automation. There's lots of processes to manage. Some basic computers might only handle one or two things like venting and heating. More advanced systems can integrate almost everything from venting and heating to irrigation, the water treatment, cooling, also even energy management, and beyond to like autonomous growing, AI growing. These are just some examples of different climate computers that have been on the market. They come in all different shapes and sizes. Some are extremely sophisticated, and each one offers different levels of technology and upgradability. This is a slide I like to use if you're going from zero automation to some automation. The first step is figuring out what you want to control. So this infographic gives a good visual overview. So at the foundation, you need a weather station to monitor outside conditions. You also need interior sensor boxes in a greenhouse to measure temperature and humidity. From there, it depends on your needs. You can add screening systems, fans to circulate the air movement, fogging units for cooling, like we talked about the roof vents, different types of heating, whether it's hot water heating through pipes or forced air heating. In a poly house, if you have double poly, you can control the inflation fans. There's also CO2 dosing, and we have also options for assisting on the irrigation side, such as EC and pH measurements, as well as dosing. As you move from the basic climate computer to a more advanced one, the focus shifts from just controlling equipment to actually measuring what's happening around the plant. That includes temperature, humidity, light levels, and the irrigation needs of the plant by measuring the plant weight itself. Through the use of grow scales is how we do that, and we track the water uptake and are able to measure a precise irrigation. So with that, I will leave it back to Dave.
All right, well, great. Thank you very much, though, guys. That was fantastic. Really great overview of what you guys provide and what's possible out there when you're starting out. So really, I mean, when we look at these things, you know, Matt, if we're going to start looking at, say, like a boom system, like what kind of efficiency gains or labor costs can we look at saving? You had mentioned, you know, a payback within a couple of months, not years, but realistically, like when you were talking about, say, just at a guess, a 2-acre facility with, you know, monocrop across benches. Consider how many people would you normally have doing the watering compared to how many of those people can you save then after adding, say, a boom system in?
I mean, at that size, we're looking at typically 2 or 3 guys that are watching over the crop, making sure everything's all right, mixing stuff for fungicide applications and things like that. At 2 acres, you know, depending on the crop, I'm not necessarily recommending a boom in every bay, but to get something like a thunderstorm in that you can quickly set up with a dosatron to dose fungicide or growth regulators to a specific part, you know, of the bay that's suffering with a fungus, or if you have a bay with multiple crop items and some need growth regulators, some don't. That's when when boom payback starts to become more and more obvious and a shorter time horizon.
Great. And I guess the same goes for you too, Peter. Like, I mean, when we're looking at real efficiency gains or labor costs, what's the real benefits here when you start to automate the greenhouse?
Yeah, well, just thinking about efficiency gains when you're screening. If you're in a colder climate, the screens actually work as the insulation of your greenhouse. So there could be a 20-degree difference above and below your screen, your top screen. So I mean, imagine the cost to heat it without even if it's double poly or not. It's an incredible savings to add in that savings, and again, depending on where you live, there's also rebates to mitigate the cost of initially putting in a screen for that.
Perfect. That's great. Well, thank you. And I mean, I guess since we're talking about efficiency, I mean, again, I guess the other side then would be really what kind of improvements can we see with crops, right? So when we're looking at, say, adding a screen, Peter, what would we be looking at to the crop efficiency?
Yeah, well, you're definitely able to maintain humidity better. If there's a certain crop that's not a vegetable, let's say you're dealing with floral, right? You're trying to keep some of that light out, so you want to block some of that light, or even diffuse the light to get a better light spread, so that you're not hitting just the top of the crop, but the light spread is actually hitting more of the plant, which is a more efficient way of actually using our free source, the sun.
Interesting. That's great. Thank you. And I guess, Matt, when we're talking about crop quality improvement, say that 10 times fast, what really would you be looking at for, say, any of the systems that you discussed today?
Everything, it all comes down to uniformity, right? Because what we're doing is correcting for errors, whether it's on irrigation and climate management, all these systems. We're trying to provide as stable conditions as we possibly can for every single plant to ensure that any, variance between plants is down to the only factor left, genetics, right? And so when you send a guy out with a hose to water, for example, that guy is never going to be perfectly even. He's always going to be one spot heavier than the other, and the next day trying to correct for the difference in growth he sees here and there. And it becomes problematic, especially as you invest more heavily in automation. When we're talking about things like weighing plants to understand the water gift we're giving them, oftentimes we're not looking at every single plant. We're taking a sample and we're using that sample to judge the masses. And so when we have a variance from one plant to the next, those automation systems don't work as well as they possibly could. So getting that baseline uniformity in is the essential building block on which you then start to automate the rest of your greenhouse.
That's great. Thank you. All right. So I guess this brings it down to where, the Prospiant thing, we build greenhouses. So, I mean, if we're speaking to a customer and we want to bring them in and say, okay, look, you guys already have a greenhouse, but, you want to start automating. What kind of things do we have to worry about for our structure? I think, Matt, you mentioned that putting up rails for a boom. What other items do you think would make a difference in somebody's structure if they're going to start automating?
I mean, the good news for greenhouse owners is we've just been designing irrigation systems around the structures that exist for over 50 years. So really, the key is knowing your structure and, if possible, having drawings for your structure. The more information that you can provide to the person who's going to build these systems for you. I can build you a boom or a sprinkler system or a flood floor to fit any building. Knowing exactly what size the building is, what size all the posts are, what size the trusses are that I'm going to hang the rails off of, or the swedge tube for a sprinkler system, knowing exactly how wide my pathways are and what sort of load-bearing capability we have if we're going to hang a gantry boom or a heavy main line or something like that. Just having as much data as you can, as good of an understanding of your structure as you can, is the starting point to all of these systems.
Great. All right. Thank you. And I guess, Peter, if they're building a new greenhouse, what are some considerations that people should have?
Yeah. So I always want to know what type. Is it glass or poly? What type of venting do you want to do? Is it if it's poly, is it direct venting or indirect venting? If it's glass, are we going to do Venlo style like I showed earlier? And each one of those has similar but also different measurements to be calculated in order to size a motor. At the same time, are we going to screen? Do we need motors for that? Are you going to put screens on the side? Are you going to vent on the sidewalls as well? And also what style? And all of these determining factors lead into more questions on how I can help size a motor for that. Aside from that, if you're looking at the controls portion, going back to the motor, what voltages are available, and then jumping back onto the controller, what are we going to control? Are you going to need heating? And then if so, what type of heating? Are you going to be dosing CO2? Do you need to control a Zwart Systems fertigation unit? Basically, what do you want to automate? What do you want to look on your cell phone and control as well?
And I think that brings us to the next thing too. I mean, really, if I'm building a greenhouse now, what things should I be mindful of in the future? Like if I'm building, say, Matt, you said it one earlier, I'm building a one base structure. If I'm thinking 10 years down the road, what things should I really start to think about now in my first that I don't have to worry about in my last? What things can I get caught up in that, may make it more costly or less efficient down the road when I start now?
Well, I always try and avoid saying hindsight is 20/20 as much as I can. So we want to try and look as far forward as we possibly can when we plan these buildings. particularly for irrigation equipment, a lot of times it is cleaner, neater, and more durable to bury some of our main lines underground. If we know that we're going to be building more structure in 2, 5, or 10 years, and we know where it's going to be, we can stub up lines to feed those future buildings. If we don't know where they are or when they're coming, then it leaves us, oh, we're going to build, 3 more acres on this side of the farm. Now we have to try and excavate and find the line that we buried 3 years ago and hope that we don't break it on the way. Tee into it, these sorts of things. Same with irrigation system sizing. Kind of the first question I ask a grower when we're planning both a new build and an expansion is, when do you want to go home? Right? You're going to come in at 8 a.m., 7 a.m., 6 a.m., whenever you want to start, whenever your grower wants to start. You've got so many things to get done in the day, and some people do like to be around while irrigation is happening. If you're that type of person and you want to be home by 4 p.m. on the worst day of the year, we need to make sure we can move enough water to make that happen for you. And if you know that you're going to be building 2 or 3x your current square footage, how much of that equipment can we put in today so you don't have to pay for it again tomorrow? Having a really firm understanding of what your crop demand is, how much crop you plan to have, and how quickly you want to get around all of it are the 3 pillars of designing an irrigation system.
That's great. Yeah, those are some really good insights. Thanks, Matt. And Peter, anything that growers should really consider when looking at any of the Ritter equipment?
Yeah. We have different flavors of climate computers to suit a grower's needs. So we have that entry level climate computer, which is that one slide, which is centralized I/O. But if you're looking for future expansion, depending on how big, then we would like to know what your dream is for your 5 or 10 year goal, to see if that's expandable. Typically, distributed I/O is easier expansion because you can place an IPC computer, let's say, in this greenhouse, and if your connected greenhouse, it's easy to expand. But if you have a distance to make up in between, then maybe it's easier to put a separate IPC and link them up in the future.
That's great. Thank you. All right. Well, I guess that really takes us through today's discussion. Tara, do we have any questions from the viewers?
Yeah, we do. The first one is, where do you think automation is headed in the future? Any exciting technology on the horizon? Obviously, AI is something we didn't really touch on, but what do you think about where automation is headed in the future?
Yeah, I do think robots are coming for harvesting. I mean, we see them a lot for harvest carts already following induction lines, but as far I see them coming for picking as well. AI seems to be proving a large benefit, and there's lots of companies out there that are good at it. It's good to have an open source platform to be able to consider these options in the future, rather than a closed network. And you have other companies that will take a picture of your crop and monitor the growth as well. So we're there now, actually. So we're going to be expanding on that, and we're going to be. It's just a matter of them getting more into the market and seeing where that evolves to.
Yeah, I mean, I would say, I mean, not that the future is now, but a lot of some of the neat technologies that are coming down the road and the large-scale implementation of those technologies are expansions on things that already exist. Growers, propagators, irrigating based on vapor pressure deficit has, it's not new technology, but those algorithms are being improved, and It's seeing wider scale use. We're seeing a lot of growers who are trying to pull more and more, I say, from the greenhouse into the computer, taking an example like the table systems I had mentioned.
Yeah.
Putting NFC tags or barcodes on plants or trays going onto these systems, being able to follow a specific plant around the greenhouse, know exactly where it is, and to intelligently control irrigation, not based on, the way that we would currently program a boom for the most part, which is, 2 passes over this area at 80% speed using MEST, now saying, oh, well, this patch of mums from week 24 is in this area, and this is what they need in their 4th week of production. Booms, figure it out. That stuff is on the horizon and is looking very interesting.
Wow,
One thing I want to add to that is I see some systems calculating the cost per SKU. So, a grower can grow, I don't know, so many hundreds of kilos of tomatoes, but at what cost? What did the packaging cost? What did the natural gas cost, and what did my water cost? It's great that I grew all this produce or flowers or whatever, but at what cost? So it'd be good to have a system that ties all of those variables into one dashboard.
Okay.
No,
We
that's
do
great.
have
And I
one-
mean,
I'm
and sorry, Tara, I'm just going to put in the plug for the next one. So that was a great question, because our next in the series is on the next step in automation. Well, the last step, I guess, which is more about AI and automating everything inside of your greenhouse. So if that's your question, please tune in next time, because we are going to do a whole part on this as well.
Okay, good. The next question, and we just have 3 minutes left, so this one is for you, Peter. How does Ruder handle mixed systems, where it's like roof vents, side vents, and energy screens all in one house? How do they
sorry, I need that first part again. How does what handle?
How do you handle mixed systems where you've got roof vents, side vents, energy screens all in one house? Is it
How does the climate computer set that?
Yeah.
The climate computer doesn't have a problem setting that. It's all dependent on the sensors and the set points that you want. So if you're in the summer time and the temperature is rising, your computer will probably open at 20%, and if that's not enough, it'll go to the next stage and next percentage. And if that's not working, then your sidewalls will open up in order to allow a breeze to come through. So, yeah.
All right. Okay, so we don't have any more questions, and we're 2 minutes away from the top of the hour, so good timing. I'm surprised we got through all of that. I thought there would be quite a bit more. We do have some contact information on the screen for Dave, Matt, and Peter, and any general queries you can send to me at info@Prospient. I did forget to introduce myself. I'm Tara Wilsworth, and I handle marketing here at Prospient. So any questions that anybody has after the fact, please reach out to any of us and we will take care of you. Thank you very much for your time. Thanks to you on the panel, and thanks to our audience as well. And tune in again in January. You should get notifications if you have signed in for those. If you signed up for a Bright Talk account, you'll get notifications. But I think it's early January. I can't remember the date off the top of my head. All right. Well, thank you very much. And
thank you for having us.
Have a good holiday season as well.
Yeah. Happy holidays.
Thank you, Mary.
All right.
Thank you, everyone.